And now it's time for Omniversica, the greatest show on the internet, with your hosts, Dan Schneider and Art Durkee.
Welcome to Omniversica, the largest show on the internet. We are going to be speaking today about art, physics, and many other things with our guest, Dr. Leonard Shlain. My name is Arthur Durkee, and I'm here in the studio with my co-producer, Dave Wesley, and then we have our other co-host, Dan Schneider, who's on the phone today.
Yeah, hi, Art. Leonard Shlain, I first got his book, Art and Physics, about a decade ago. And it's it's a real interesting book because I've always been interested in all the arts other than poetry, but I never had the vocabulary quite to handle the visual arts, especially modern art. I could understand why a lot of the more classical Renaissance art was good or bad, but I could look at a modern art painting, and I could say, well, that's good, and I know it's good, but I couldn't describe why. When I read the book Art and Physics, I've always had an interest in physics, and I always found it to be a book that melded the two very well, and I was able to understand why, for example, I like Dali paintings, or why I like other paintings by other painters, and I consider it one of the best books ever written on art, and one of the 4 books that I've always found in my life to be one of the influential books, along with the Lauren Isley biography, All the Strange Hours, Leaves of Grass by Walt Whitman, and the autobiography of Malcolm X. I consider Art and Physics one of those 4 books that really stick with me, and I'm glad to have Dr. Shlain on the line with us. And in this first segment, I guess we're going to talk a little bit about Dr. Schlain's career, because he isn't a professional artist, and he's not a professional physicist, and he's not a professional in gynecology either. In regards to his new book, Sex, Time, and Power, he is actually a surgeon. So, Dr. Shlain, how did you get into writing about subjects outside your normal purview?
Well, let's see now. I would describe myself as a very curious individual. I have a day job, and that is I'm the chairman of laparoscopic surgery at California Pacific Medical Center in San Francisco, and I'm an associate professor of surgery at UCSF, which means that I train young surgeons as to how to operate. I went to medical school in Michigan and took part of my surgical training at Bellevue in New York, and was in the Army for a couple of years, and then came back out to California, where I knew I was my spiritual home and I had to live, and I've been practicing there ever since. I started out as a general vascular and thoracic surgeon. I've worked with the heart team. So I've sort of started out as a jack of all trades, and in the last 10 years or so, I was a pioneer in this new kind of surgery called laparoscopic surgery. So I've subspecialized in that because it gives me more free time to write the books that I want to write. The question as to how this all came about, it's rather unusual. I had freshman English in college, and that was the extent of it, because I took one of those accelerated pre-med courses that telescoped 4 years of science courses into 3, so I could get an early admission to medical school. And then at the age of 37, I was diagnosed with a non-Hodgkin's lymphoma, and I was facing my mortality because I had 3 little children, and it just started my practice, and suddenly I had somebody telling me that a good possibility I was going to die. So I underwent 6 months of radiation treatments and 5 operations and a lot of debilitating complications, and just basically had a really bad year in my life.
Yeah, it sounds like it.
And when I finished that, I had been a fellow of the American Cancer Society, had been operating on a lot of cancer patients, and that was the year that Kubler-Ross wrote her book in 1974, and that was also the year that the United States was grieving over Vietnam and Watergate and a whole bunch of other things.
That was her book on death and dying?
Yes.
Okay.
And somebody had a conference on death and dying, as if people don't know how to die, but at any rate, if you remember, that was a hot topic back then. And someone invited me to give a talk at this conference because they thought that because I had been on both sides of the knife, I would be someone who would have an interesting perspective.
Yeah.
So I ended up giving this talk, which I had put together, and I'd never quite done anything like that before. And afterwards, a man by the name of Charlie Garfield came up to me and said, that was a fabulous talk. Do you have that written down? And I said, well, I've made some notes. And he said, well, I'm editing a book called Stress and Survival, The Emotional Realities of a Serious Illness. And I have Norman Cousins and Linus Pauling and Carl Menninger and Anne Selye. And I'd like you to write that chapter just as you said it. And of course, the most extensive bit of writing I'd done to that time was progress notes in the chart.
Right.
So I said, well, I don't know if I can do that or not, but I'll give it a shot. And I did it. The book came out. It won an award, and then this amazing thing started happening. I started getting phone calls from people in Minneapolis and Florida and Texas, and medical students had been given the chapter when they started their third year of oncology, and patients were being given the chapter when they were starting their radiation therapy. And I said, gee, something I wrote actually affected people. The publisher suggested that there was such a good response to the chapter that I should expand it into a book, sort of a Bernie Siegel kind of book. And I considered that, and I thought, if I do that, then I'm always going to be a victim. I'm going to be writing about, and there's so many books of how I overcame my alcohol, how I overcame my drug addiction, how I survived my heart attack.
Well, you might get pigeonholed as a New Age writer that way.
So I said, I don't think I want to do that. I want to move on. I don't want to constantly be reliving this whole thing. And I had this idea about art and physics, and I started to write that book, and all my friends and colleagues, their eyes would glaze over when I told them what I was doing. And it was very interesting. I just kept plugging along, and people told me, they said, well, you're not an art historian and you're not a physicist. How could you possibly write this book? And I said, well, I'm a curious guy, and I remember when I was a young surgical resident, I watched somebody take somebody's aorta out and replace it with a plastic tube. I was sort of astonished in this 10-hour operation. And just like that line from Chorus Line when they asked the dancer, why did you want to become a dancer? And he said he saw somebody else dancing. He said, I can do that. So I sort of felt like, well, if I can learn how to take out somebody's aorta, I'll be able to do the research necessary to write a comprehensive and accessible book about two subjects that have always interested me. So I ended up just working away at it, and then one day I gave a lecture about it because that's what I was doing to force me to keep writing, and I would give lectures, and that would kind of encourage me to organize my thoughts and put them down in a coherent manner. And again, some literary agent by the name of Robert Stricker came up to me and said, this is fantastic, you have this written down.
And this time you can say yes.
I've been working on it, but I don't really have it in any form yet. Well, he took it back to New York, and the next thing I knew, I had 8 major publishers bidding on it.
Wow.
And the rest is history. The book came out, and it was a national bestseller. It's been translated. It's now used as a textbook in numerous high schools, universities, art schools. And I continue to receive emails from people now all over the world who say that this book has really affected them in a very positive way, and they consider it one of the best books they've ever read.
Now, it took about a dozen years, though, because I'm looking at your preface. You said in 1979 you had one of those daddy moments when you couldn't explain to your daughter why a painting was good or bad, and but the book only came out in 91, so there's quite a bit of a gap.
Well, for sure. I mean, I was, my full-time day job was as a surgeon. It doesn't leave a whole lot of time, but I worked on this thing on weekends and vacations, and and I went through some more turmoil in my life, and that kind of set things back. But in the end, I was sort of doing this thinking that, well, this is a nice hobby, and I don't know if anything will ever come of it because everybody was so discouraging.
Right.
But
it obviously sounds like you tapped a nerve, though. I mean,
for sure.
Yeah.
For sure. I mean,
based on the response.
Yeah, for sure. But the book's thesis is different from most art history books. Most art history books begin with the premise that they're going to discuss the art in terms of its pedigree, meaning who influenced this artist in the past, or they're going to discuss how the artist is tapped into the social times that he lives in, and he's going to express graphically the times that he lives in.
Right, putting it all in context.
Or the Freudian view that, let's discuss this artist's art in terms of how his personal angst or his childhood or the events in his life affected his art.
Right.
So that's the three major ways that art is interpreted. I basically was struck by something that Marshall McLuhan had said when I read Understanding Media. And he said, that the artist is a weather vane. The artist is the first person in the culture to see things in a new way. They project that image using image and metaphor. And most of the other people in the society don't. They're not ready for that vision yet, and they don't quite understand it. And art has been used to predict all kinds of social movements. But I thought, art has been predicting all of the major paradigm shifts that have occurred in science.
Right.
So the thesis of art and physics is basically, as Ezra Pound said, that the artist is the antenna of the race.
Okay.
And T.S. Eliot once said that great art communicates before it is understood. So I basically took those two ideas and said that the reason that modern art is so difficult to interpret is because art's been around for 40,000 years, and every single culture in the world creates art. The thing that is common to all people's art in all historical times, in all cultures, is that the other members of the culture could understand the art.
Right.
I mean, it had never happened before until this latter part of the 19th and the beginning of the 20th century, that art disconnected from the public so that people couldn't understand it. I mean, can you imagine somebody in Renaissance Italy standing before a Raphael and saying, "Gee, I don't get it. What's this artist trying to say?" So art has had all that quality, and at the same time, science is currently our most prominent belief system, meaning that this is how we explain how the world works.
It's almost our creation myth these days.
Well, previously, it was shamans and then religion and philosophers and early scientists. And the thing that was common about all earlier belief systems is that other members of the culture could understand it. I mean, you could disagree with Copernicus, but you got the general drift of what the hell he was trying to say.
Right.
And then along comes modern physics and, space-time continuums, quantum jumping, electron tunneling, all of these black holes, all of these concepts become so recondite that it's very difficult for the average person with an education to even understand what they're talking about.
Well, let me just jump in here because you mentioned before about art. You gave the T.S. Eliot quote, and you mentioned too about art being like 40,000 years old. And this segues into because I've read both the Art and Physics and the Sex, Time, and Power book, and there are some connections. And one of the things I know when I was talking with Art Durkee about, when I saw you do your presentation in Minneapolis a couple of months ago, was the idea that there was this great a boom in representational art about 40,000 years ago, and I know Art Durkee disagrees with that, and because I think there has been art. You had mentioned that there has been discovery of Neanderthal art.
Well, we don't know for sure. I don't know that I can disagree with it on any scientific basis.
Again, we're talking representational, not scratches on stones and bones.
Yeah, but basically what I was referring to was they've discovered this dig of a Neanderthal cave. I believe it's in France or Italy, where they think what they found is a primitive musical instrument, a bone flute of some kind.
Well, again, that's not representational art.
No, it's not representational art, right?
But it would be abstract. I mean, music is an abstraction.
Well, I mean, first of all, I'm familiar with that report, and
it's a controversial report too.
Yeah, there are a lot of people that it's sort of like that Shandahar cave 60,000 years ago in Iran, where they found a Neanderthal burial and flowers. And everyone said, "Oh, see, they buried them in flowers."
Right.
And that has been disputed since, saying that those are pollen grains that were blown in by subsequent winds. So we don't really know whether that was a burial.
Yeah, some of it's speculative.
When you get into a gray area like this, it's very controversial, but it doesn't become controversial when you unearth a antler bone that is half man, half lion, and you say this clearly is representational art. So
or the cave paintings in Lascaux, for example.
Well, Lascaux is 13,000 years.
Right.
Chauvet originally was dated at 28,000, and now they're upgrading that. They think it's more recent.
Okay.
But it's one of the mysteries to me is that the Homo sapiens has been around for 150,000 years. We know that from molecular biology, give or take.
Right.
10,000 years, and we had a 1,400 cc brain at the very outset of our species, and for the first 110,000 years of our species' existence, we created zero representational art. Now, it's possible that somebody's going to unearth a great big catch of it in the near future, but that's highly doubtful because, my God, archaeologists have been fanned out all over the world searching caves and looking for great works of art, and they have not been able to come up with anything.
Well, and if there was representational art, it's sort of hard to prove its date sometimes because if it's done on a material that will decay and turn to dust.
Right.
I mean, we
do know that caves can preserve art for very long periods of time because of the no climate change. But nevertheless, I don't think that there's any evidence that humans were sophisticated enough to be able to make representational art for the first 110,000 years of our existence. And it's just the question I ask in Sex, Time, and Power is, if our brains didn't get any bigger for the last 150,000 years, what took us so long to finally start making representational art? Number one, and number two, what would have been the impetus for us to start doing it to the point that every single culture in the world makes art?
Well, let's leave that here as we end this segment, and when we come back, we'll pick up on that thread, and we'll just pick up and talk a bit more about art and physics, and also sex, time, and power. So let's listen to a musical interlude and come back with Dr. Leonard Shlain.
And we are back talking with Dr. Leonard Shlain, author of Art and Physics and Sex, Time, and Power, among numerous other works.
Not numerous. My first book is The Alphabet versus the Goddess.
Thank you.
Well, I wanted to just pick up on where we left off the last segment. You had talked about 40,000 years ago there having been this big explosion. And earlier this year when we spoke with Dr. Lynn Margulis, I had mentioned the Devonian explosion, which was back, what would it be, about 450 million years ago, the sort of radiation of life from just single-celled animals to a lot of new genera. And she took exception to that, and she basically said that the only people who really believe in that kind of idea that things just explode out of nothingness are people who don't really look at things. Because she had gone on about about 3.5 billion years ago. That was when the real explosion happened, and single-celled animals just really radiated into many different types and forms and whatnot. And I'm also thinking too about Big Bang cosmology. I think there always seems to be this idea that there needs to be one single moment, and I'm just wondering, when you talk, Dr. Shlain, about 40,000 years ago, there having been this sort of big explosion of representational art, could it be just that there isn't a fossil record, and if we do find more things, it'll be more gradual? Because it just seems odd that 40,000 years ago.
I don't know. First of all, we're confusing evolutionary biology from simple life forms to more complex life forms to cultural changes that occurred in the species when its behavior drastically changed. I mean, you can't doubt, if you were to make a graph, that we discovered agriculture 8,000 years ago, the writing 5,000 years ago, the Industrial Revolution 200 years ago, the Technological Revolution 50 years ago. Each one of those things didn't happen gradually. They were just sudden, dramatic changes that occurred in a species' behavior as a result of a discovery. So the question is, speaking to the earlier evolutionary changes, Stephen Jay Gould would disagree with Margulis because he and Henry Lewontin came up with this theory of punctuated equilibrium,
right? Mm-hmm.
And that the whole concept that a species changes very, very gradually into another species, and that we just can't find the gaps, and that's the reason why. He said you can't find the gaps because there are no gaps, and that in point of fact, punctuated equilibria is the concept behind most species radiation today, and that you have an isolated group of a species that suddenly has some environmental stress acting upon it, or some environmental bounty that suddenly presents itself, and this one species goes through an evolutionary bottleneck, and suddenly out on the other end comes an entirely new species with very little gradation in between. So I think that you were referring to Lynn Margulis's discussion about the Devonian and the Cambrian and these explosions that occurred very, very, very long ago. And I don't know that you can compare those to behavioral changes that occur in humans.
Well, the point is, though, it seems that scientists sort of like to leap on these ideas of these big moments, and it should be said, punctuated equilibrium is far from fully accepted. I mean, Richard Dawkins, for one, sneers at it, and he's one of the biggest leading lights in biology.
Look, there can be no doubt that the emergence of Homo sapiens was about as unexpected an event. I mean, Homo erectus with a 900 cc brain that was gradually, slowly increasing, was doing just fine on this planet.
Right.
And nobody knows why suddenly we had a whole pound of brain tissue go from a 2-pint brain to a 3-pint brain in the space of an astonishingly short period of time. We come out on the other end with these enormous hypoglossal nerves, these great big upper thoracic nerves controlling respiration, the tallest larynx in animaldom, and we're obviously talking. And nobody knows why we started to talk in the first place. Nobody understands why we suddenly developed this enormous brain. So there are definite discontinuities that have occurred in the evolutionary record, and I would dispute those that say it's all just a real gradual shading from one slightly larger brain to another slightly larger brain. Well, obviously, events happen that profoundly change a species. Look at agriculture. Agriculture didn't happen gradually; it happened suddenly. Right. Same thing with writing.
Well, let me just ask you, because when I saw you speak in Minneapolis, you had talked about the origin of the human species, and you talked about like the aquatic ape theory, and I think you had mentioned ideas about how bipedalism evolved.
Yes.
What basically do you have an overarching theory about how why the
well, nobody knows why we stood up. I mean, 4.5 million years ago, our last common ancestor that we split away from the other two chimpanzees that are to our cousins, the bonobos and the chimpanzees, and we became the first heel-to-toe bipedal mammal to ever walk on the face of this earth. And for the first 2 million years of our standing up, and it isn't at all clear why we did it, as Owen Lovejoy, the anthropologist, said, for any quadruped to stand up on its hind legs is an insane thing to do. It's just plain ridiculous. I mean, if you took any guy listening to this program and took his clothes off and parachuted him into the center of the African savannah tomorrow, how long would he last?
Right.
I mean, he'd be cat food in no time flat. And there's no single prey that you could run after and catch with your bare hands. So when you stand up, it makes you real easy to be knocked over.
Right.
You're not fast, and it's not at all clear, since primates mainly survive by scampering into trees to escape from danger. When you start walking on the flat ground, you can't climb a tree very quickly, and as a result, it's not at all clear why we started walking. Well, but I think that after about 2 million years, we dimly survived that. All we needed was a really, really big brain, and then we could imagine a great weapon that our free hand could brandish.
Well, you mentioned, as far as I know, other than the aquatic ape theory, there's the theory that by standing up, there was less of the body exposed to the sun, so it was easier to stay cool. Also, that by freeing up our hands, we could make weapons and go after big prey because we did have opposable thumbs.
Yeah, well, in Sex, Time, and Power, I think I forget how many there are, but I think there's about 17 or 18 current theories out there as to why we stood up. And, I've learned in surgery that when there's 8 different ways to fix a surgical problem, probably none of them work very well, because if there was one that really worked really, really well,
that would be the one that everyone
that would
did.
be the one everybody would be using. So when there's 18 ways to fix something, you know that none of them work very well, because it's the Darwinian principle. If one is superior to everybody else, then that's the one that wins out. And when there's so many different theories for why we started talking, why we stood up, why we got a big brain, why all these questions that are the most basic questions remain unanswered.
Mm-hmm.
Yeah. Well, let's talk about, early in the book, Art of Physics, you talk about Plato's cave and the in there, out here, or in here, out there paradox about reality. And I'm just wondering if this maybe is how art may have developed. Would some ape that became, can art is art able to be made without a recognition of self, I guess I'm asking?
Well, I don't think so. I think that art is we don't know why people started making art in the first place. I make the point that I think that a very dramatic thing happened 40,000 years ago, and that is that a critical mass of humans finally figured out they were going to die. All the animals on this planet experience fear when faced with life-threatening danger, but there's nothing in the observable behavior of any animal on this planet to indicate that they have a knowledge at an early stage in their life that they're going to die. Mm-hmm. Now, every human makes that realization somewhere when they're about 7 or 8 years old. A 5-year-old speaks grammatically correct sentences with subject, verb, object, and direct object, and they also know that they're going to have a birthday in 1 year from now, but most 5-year-olds do not understand they're going to die. And I use the kind of analogy that the lifespan of the human species can be compared to the lifespan of a single individual, and we've had the same relative degree of insights. We're 150,000 years old, and I think at about 110,000 years old, we discovered that we're going to die. Mm-hmm. And the knowledge of death is one reason why people create art. They want to achieve some degree of immortality by creating something that lives on after them.
So it's a function partly of self-awareness and consciousness, then.
Yes, I went to the cave in France called Garges,
right,
which contains 30,000 years old. It contains thousands of handprints. And you look at these handprints, and you know that they were made by people who lived, 10, 15,000 years ago. And what struck me when I visited the cave is right next to the handprints, at the entrance of the cave, which are much deeper, the handprints are much deeper in the cave, but near the entrance is all this graffiti written by French people who came into the cave in the 16th, 15th, 14th century and carved into the rock. Marie loves Marie loves Pierre, 1641. And
right.
So, what's the impetus why people want to do that, if not for the fact that it's like a dog marking their territory? It's you're leaving something that is outside of you that lives on after you're dead.
Mm-hmm. Art is always has often been described as that primal scream in the void. I am here. Kilroy was here.
It's what Emily Dickinson wrote when she wrote, when this you see, think of me.
Yeah.
The Roman poet Horace, when he achieved this great degree of fame, he wrote, I have touched the stars with head sublime, I shall not altogether die, because he understood that by creating a work of art, he had created immortality.
Mm-hmm. Now, just to be clear for our readers, when you say that human beings understood death or discovered death about 40,000 years ago, we mean death as a thing, not just as a process, because, elephants has been supposedly known to have graveyards, and some whales have been known to just go off.
Yes, but again, right. All dogs grieve for their masters. Mm-hmm. But there's nothing in the behavior of a dog to indicate that the dog is aware
of its own death.
That at some future date, 5, 7, 10 years in the future, it's doomed.
Right. That's what I mean. The knowledge of death as a thing, not just a process.
All animals see death all around them, but but once humans grasped that they were going to perish, then that suddenly changed everything, because whereas other animals experienced fear, we invented anxiety. We started having existential despair And when you think of it, other animals don't commit suicide, and other animals don't sit and wake up in the morning and say, what must I do to accomplish in my life to give my life meaning? That's not a concern for lions sitting on the Serengeti.
Now, we've only got a couple of minutes left in this segment, and I want to just sort of end this segment and then begin the next segment. In Art and Physics, there's an interesting passage, or several pages, where you talk about the connection between Isaac Newton and Leonardo da Vinci, and how sort of Leonardo, you think, got sort of the short end of the stick in terms of historically. And why don't we take a break, and when we come back, you can expound on that. And I know we're leaping about 40,000 years ahead, but I'd like to, when we get back, talk about the Leonardo-Newton connections, and then go from there more on your book on art and physics.
Okay.
And we are talking once again with Dr. Leonard Shlain. I'm Art Durkee, my co-host Dan Schneider, and we were just talking about, in your book Art and Physics, the connection between two well-known Renaissance names, Newton and Da Vinci.
Right. Well, the book is, the premise is that the visionary artist anticipates a new way to see the world, and usually presents it in the form of image and metaphor, just prior or simultaneous to a physicist who conceives of a new way to think about the world and expresses that idea in numbers and equations. That the artist's images, when superimposed on the physicist's equations, actually fit quite nicely. And you brought up this chapter I have on the connection between Leonardo and Newton, which is a chapter mainly acknowledging that Leonardo's scientific discoveries prefigured a lot of Newton's discoveries. Leonardo is not prominently displayed in scientific books.
No.
Because they don't feel that he made any great contribution to science, which I'm actually writing a new book entitled Leonardo's Brain. So,
great.
And it's about why Leonardo was so creative that if you gave only 2 Nobel Prizes a year, one in art and one in science, we would have an enormous number of geniuses who would claim the award in art, and we'd also have an enormous number of geniuses who would claim the award in science. But who could you name who could have won the award in both categories?
Leonardo.
Hard-pressed to come up with 5 candidates, and after some consideration, you'd have to eliminate 4. You'd only have the name of Leonardo da Vinci. And Leonardo, I find to be a fascinating character because, obviously, I wrote a book on art and physics, and I'm fascinated by anyone who could have been so creative in both the field of art and the field of science.
One of the things I find fascinating about Leonardo, and I'm a big fan of Leonardo, I've read through the notebooks a couple times, I have his collected works. One of the things that intrigues me the most is that I think this ties into an idea about paradigm shifts. This is that Leonardo basically looked at everything equally. It seems to me he looked at a science problem and an art problem as equivalent problems. If you look at his sketchbooks in the notebooks, a lot of them are, the famous Vitruvian Man, which is the proportions of the human body laid out geometrically in a circle and a square. That seems to me to be emblematic of the fact that Leonardo integrated both views, art and science, art and physics. He made no distinctions, it seems to me.
Right, and on the same page, I mean, the thing that fascinates me is that, we now have done so much work on brain mapping that we now know where various functions reside in the brain, and basically in my new book, I'm going to try to do a posthumous brain scan on Leonardo da Vinci to try to figure out what kind of brain was wired in this man that allowed him to be so creative in these 2 fields. And we know a lot about his brain because we know that he was a left-handed, mirror-writing, ambidextrous, gay male who was composed music. And those are all different things that we now know from MRIs and brain mapping have different configurations within the brain. So,
is there any tissue of Leonardo left? Was he grave robbed? Or?
No, well, I think he was. We don't even know exactly where he was buried.
No,
he was buried somewhere in France.
Because I was thinking, was it his brain or was it Einstein's brain that famously was dropped on a floor? Was it Einstein?
It was Einstein's brain. A pathologist kept it in a jar for many years.
Yeah.
Finally, somebody rescued it.
Whoops. Well, later on in the book, I know one of the painters that appears the most, and one of my favorite painters is Edward Manet. And you have, probably more illustrations of his work. And
well, I actually was. I had more material. I had to take it out. One of these days, if I ever get around to it, I'll write a book about Manet and what a revolutionary he was in the sense that he anticipated so many things that later in science became major issues. For example, he began to, paint figures that didn't seem to be grounded in gravity. I mean, they were floating in midair, like his dead Toreador.
Yeah.
And he raised all these questions, which of course prefigured Einstein's calling into question the whole Newtonian concept of gravity as a force. I mean, Manet also, I'll give you some examples of what this art and physics is really about. Like, Claude Monet, for example, was the first Western artist since the Dark Ages to start painting the same object over and over again from the same angle of vision.
Yeah, La Rouen Cathedral.
Right, but at a different time of day. And although he was studying the effects of light, and by the way, I'm not saying that the artist wakes up in the morning and says, I'm going to paint a prefigure of a physical principle that hasn't been discovered yet. I'm just saying that the artist has an intuitive way about them that's what art is.
Yeah.
And,
right.
When Monet is basically saying, in essence, that, look, and when I paint haystacks in the summer and I come back and paint that exact same haystack in the winter, I'm saying, in essence, that in order for me to show you the essence of haystacks, you have to see not only where they're located in the three vectors of space, but you also have to see how they change in the three durations of time. So it's 20 years later, and Minkowski, looking at Einstein's equation, says, Eureka! This leads inexorably to the conclusion that there's a next higher dimension that I, Minkowski, will name the space-time continuum.
Right.
And he then concludes that the fourth dimension, which everyone thought was a fourth spatial dimension, was actually a combination of the three vectors of space, height, length, and depth, combined with the three durations of time, past, present, and future, to form this fourth dimension. And in my presentations, I go back and forth between Monet's haystack series and a space-time diagram from Minkowski, and say, look, there's really no difference between these two sets of images. One is being expressed in the form of a graph and numbers and equations, but the other one is being expressed metaphorically using images.
Yeah, and I think Manet is, to me, the most important figure in the whole art and physics book, because not only is he the bridge between art and physics, but for me, he has enough representational painting style in his paintings, but it's slightly shifted that it's almost it's the point where the river breaks off, and it helped me to understand some of the later art that you talk about in the book, with the things like the dead Toreador, or the picnic scene where you have the woman who would be like a 10-foot giantess if she were actually. And so to me, Manet isn't just the bridge in the book between art and physics, but he's sort of the break. In other words, he's sort of like what Walt Whitman was in poetry.
You'd call him a punctuated equilibrium, right?
Yeah.
Yeah, in a way.
Yeah. Let me just talk, because you had mentioned visionary, and I've mentioned this, I think, maybe once or twice on the show before, and Art and I have talked about it. I've always had this idea regarding just plain intellect, that there are basically three types of intellect. There's a functionary intellect that would be measured on the standard IQ scale, and that to me is just people looking straight ahead, to use a metaphor. Then there are what I would call creationary intellects, people who can see farther, and these are most artists. And then there is sort of visionaries. These are people who can see far ahead and maybe a little bit around the corner. And as I've met people, whether it's in the arts and sciences, I've tended to be able to put people in sort of these three kinds of categories. And I'm just wondering, when you talk about visionary, to me, visionary is sort of like, if creationary intellect is sort of a functionary squared, visionary would be sort of functionary cubed. And when you talk about the visionary, you're talking about sort of that Keatsian negative capability to make these irrational leaps, but they somehow hook up. Is that
right? I mean, I'm quite convinced that it's sort of like if you're looking at a pond in the morning, you'll see a fish jump out of the water, and the fish jumps out of the water. The fish has an eye that's designed to see in water. So when it jumps out of the water, it gets a brief glimpse in air of something that it can't see very clearly.
Yeah.
Then it falls back in the water. So the other fish say, "So, what did you see?" And the fish says, I caught a glimpse of another world. I didn't see it real clearly, but there's something else out there. Now, a lot of fish never jump out of the water.
Right.
I think that's the way most people in this world are.
Right.
Yeah.
But there are these occasional, what I would call visionaries, that are able to glimpse another reality and be able to express it either in the form of image and metaphor, or like somebody like Heisenberg, who was able to formulate a series of quantum matrix equations to describe mathematically a reality that he said we could not visualize. Now, don't forget that we have an enormous portion of our brain devoted to vision, because we're primates and we needed it to swing through the trees without wings to make sure we didn't fall. So monkeys, 1/3 of their cortex is all about vision. So here we have a physicist who's saying you, the most visualizable creature on the planet, cannot visualize exactly what an atom looks like. That the process of looking at an atom changes what it is that you looked at.
Yeah.
So because if the atom is minding its own business with its electrons twirling around it, and you decide to look at it, you have to shine a light on it, and shining a light on it puts energy into the system. So now the atom is not what it was before you looked. Well, Marcel Duchamp made a wonderful construction where he turned to his patron, Walter Arnsberg, and said, "I want you to take an object, don't tell me what it is, and put it in the center of this ball of twine." And then after Arnsberg did it, he gave it to Duchamp, who did not know what the object was. He then put 2 steel plates and 4 screws and put the twine in the center of this construction. It's called With Hidden Noise. When you pick it up and you shake it, you can hear that there's something at the center, but you don't know what it is. But you can find out what it is by taking off the 4 screws, taking the 2 plates off, unwind the twine, and then you'll know what it is. But of course, it's no longer what it was before you looked.
Right.
So here's you have an artist who managed to cleverly come up with the most unusual art construction, which conveys to the public a principle that is almost impossible to understand when the physicists try to explain it to you.
Right. And you had mentioned in your book, and a really terrific book that I subsequently read after reading Art and Physics, Edwin Abbott's Flatland, which I think perfectly illustrates, and it's a wonderful book that it was written in the Victorian era, is astounding, I think.
Right.
But talking about we were talking about some of Manet's paintings showing time. Another important artist that I never understood a lot of Oriental art, but you talk a bit in your book, Art and Physics, about Katsushika Hokusai's 36 Views of Fuji.
Yes.
And I was wondering if you could talk a little bit about what he was trying to do there in representing time.
Well, I've written this book, The Alphabet versus the Goddess, the conflict between word and image, which proposes that the invention of alphabet literacy reconfigures the brain of anybody that uses it. And that's what brought patriarchy and misogyny and the disappearance of the goddesses in Western culture. And learning how to read an alphabet it's a linear sequential process, and it's no coincidence that the West developed linear perspective, where the East never did. Now, the East would never think to represent something from only one point of view, because they know that everything has multiple points of view. So linear perspective became the darling of the West, and it was like for 300 or 400 years there was no Western artist that ever conceived of making a work of art without representing it from a single fixed point of view, as that was stationary.
Yeah, with horizontal perspective and everything.
The Eastern concept has a very different notion about space than the Western concept. Yeah. And I have 3 chapters in Art and Physics, one about children's art, and the other one is primitive art, and I use primitive in its historical meaning rather than the pejorative sense, and Eastern art. And these are the 3 cultures that have very different notions about space and time than the linear sequential notions of absolute space and absolute time that Newton came up with, and linear perspective in art.
Well, and also Eastern art seemed to be ahead of the West in terms of acknowledging that art is an artifice. I'm looking here, for example, in Art and Physics on page 167, Toshisai Shiraku, the paint, sort of the flat, the portraits that were done in Eastern art. There's no shadow, there's no dimensionality. It seems that there's an acknowledgement that this is not reality. Deal with it, and that seems to be quite, to have been centuries ahead of the West in that sense.
Well, shadow is a means of telling time, isn't it? I mean, sundials, and I mean, you can look out the window after you wake up from a nap and estimate what time of day it is by just looking at the shadows and figuring out, where you are oriented in time. But De Chirico and a whole bunch of other artists in the West began to tamper with the, they would show shadows falling at a time when it should be early morning or late evening, and the clock on the train station says 3 o'clock. Now, it can't be 3 in the morning, and it's certainly not 3 in the afternoon. So he's challenging our notions about space and time at a very time when the physicist is telling us that our conventional division of reality into two compartments, space and time, is an illusion, and in point of fact, it's a combination of the two, space-time.
Well, let's end this segment now, and when we get back, we'll finish up talking about art and physics, and we'll talk a bit more about your most recent book.
And we're back talking with Dr. Leonard Shlain, and we have some more to talk about with art and physics before we get into Sex, Time, and Power. Dan?
Yeah, well, Art, you touched in your essay about some aspects of art and surrealism, and I'm looking here in Art and Physics on page 350. And this is one of my favorite all-time paintings, Agnostic Symbol by Salvador Dali. And I know, Leonard, you give an interesting explanation about light, and it touches on black holes and mass, and how this painting in 1932 really was decades before even the discovery of black holes, yet it all ties in, and I wonder if you could explain a little bit about that particular painting.
The painting is a incredibly long spoon bending around a indeterminate object of mass, and then the spoon continues on its straight line again. And what struck me about that painting by Dali is that he was making a very accurate rendering of what happens to light when it passes near objects of mass. It gets bent, and there are numerous drawings in physics textbook showing how light bends as it passes by an object of mass. I mean, in 1919, it was Eddington that was able to prove that Einstein's theory were correct by showing that during a
total
eclipse, that the stars had changed positions in the sky, where they were when the sun wasn't there, when the sun is there. So that the mass of the sun was actually bending the light rays. So here you have a painter that, Dali was not particularly scientifically inclined, and I returned to Dali on several occasions because not only did he come up with that idea, but he also did his famous crucifixion scene of the Hypercubus, when he has Christ floating in front of a very unusual cross that has a projection in front and in back besides being the standard cross. And that's a geometrical figure that represents a hypercube of the fourth dimension. So, I mean, Dali managed to, even though many of his paintings were done after these scientific discoveries were made, if you read the biography of Dali, he really had no great interest or was no great scientist, and he was just dabbling, but he managed to give a image that the rest of us can use to begin to understand what is so fascinating and unimaginable about science. One of the most famous paintings in the world, as far as I'm concerned, is Persistence of Memory by Dali, which shows melting watches on a sandy beach crawling with ants. Now, if I go to the Daughters of the American Revolution, or I'm speaking to the Carpenters Hall, and I mention the name Dali, somewhere in the response will be melting watches. And if you look at this painting, what it really is it's melting watches on a sandy beach crawling with ants. Well, ants are the only insects that I know of that are associated with time. which is the ant and the grasshopper, the patient. And ants sort of look like hourglasses. I mean, they're shaped like hourglasses. So here's an artist that conflates four very important metaphors for time. One are ants, two are sand, three are melting watches, and four is the hourglasses. So at some unconscious level, when you see this painting, your mind swings around to ask the question, well, what is the meaning of time? What does it mean that time flows?
Right.
And basically, I think that a lot of the modern art that has been created in the last century was for the purpose of educating the public, getting them used to these new ideas of a new way to think about the world, which were coming forth in physics. So that's basically the whole premise of art and physics.
Yeah. I know in art and physics, the focus is mostly on the development of the human mind. And in your latest book, and maybe perhaps in your second book, it seems you focus more on the body and how changes in the body affected the human...
Well, the second book, The Alphabet versus the Goddess, is based on my knowledge. You see, I did a lot of vascular surgery operating on carotid arteries to the brain. So it's long fascinated me that we humans have this extraordinary split between our hemispheres, where we basically have two different computers. Even though each hemisphere looks alike, they're functionally different. The right hemisphere processes information in space, and the left hemisphere processes information in time. It's almost as if the left hemisphere is a new sense organ. It just doesn't happen to have openings to the outside world. And this is an extraordinary development from an evolutionary point of view, because there virtually are no other handed animals. I mean, other animals don't show hand preference like humans do, and they don't have the capacity to speak 500,000 words and mix them up in sentences of infinite variety. So Alphabet versus the Goddess is primarily about what happens to a culture when it shifts from an oral culture, a shamanic one, to one based on alphabetic sacred texts like the Old Testament, New Testament, and Quran. And we know that every single culture in the ancient world, both men and women worship goddesses, and then along came these three Western religions, and there's only one God, and he's indisputably male. The question in that book is, what event in culture could have been so immense and so pervasive that it changed the sex of God? And I propose that it was the invention of literacy, particularly alphabet literacy. But Sex, Time, and Power is also about what changes, because that book was about patriarchy and misogyny, and I wanted to understand what it was why human males and females mate in such a strange manner that we are so different from the reproductive life cycles of all the other animals, and what was the evolutionary basis for why that would have come about. So those are the questions I try to answer in Sex, Time, and Power.
Well, it's just interesting you mentioned handedness, and just I don't want to get off too far, but I just read, I think it was in Discover magazine or Natural History a couple of days ago, that they have discovered handedness in some rattlesnakes, that where they put the heads, does a rattlesnake, when it coils, does it coil its head inside to the left or the right? And apparently they have discovered, I guess you would call not bilateralism, a lateral preference, one way or the other. So I don't know if that is a prefiguration of handedness.
Well, there are songbirds that have hemispheric lateralization, and there's a few species that are interspersed, but there's no animal that has it to the degree that humans do.
Okay.
And the handedness goes in hand, if you will,
as it were,
with language, because language is such a complicated computer program that it requires a lot of real estate in the brain in order to function properly. And in order for language, which is a linear, sequential process, I mean, you say one word at a time, one line at a time, one sentence at a time, you have to process words in time. You can't process them in space, whereas you could look at somebody and holistically take in their face, their body language, how they're dressed. I mean,
well, and that's how we look at visual art too. Painting, sculpture, photography.
Yes, of course. So it's the difference between the holistic versus the sequential way of processing information, and it is that brain development that happened in humans that has so remarkably separated us from all the other animals, because, there are a lot of smart animals in the world, but the one thing you can't teach your dog, no matter how smart the dog is you can't say to him, Fido, I want you to meet me on this corner in 2 weeks from now, because the dog will not keep the appointment.
Right.
So,
one of the things I find interesting about Leonardo is that he promotes all the time. He created exercises. He talks about the virtues of ambidexterity, and he talked about this is what he did to develop ambidexterity. And it seems to me, I wonder sometimes if handedness hasn't gone too far, and that we don't have.
I agree. That's the whole point of Alphabet versus the Goddess, that we have allowed our culture to become so left brain, so aggressive,
that's
so
unbalanced,
macho, yang, beta mode kind of thinking, that we have these constant wars, and we had to destroy the village to save it, and all this excessive rationality that has produced, the most literate country in the world, Germany, sinks into the most
most insane
madness in World War II, and we have a president who right now says that because we're having so much progress in Iraq, that's why we're having so many people killing. So we need more progress.
One of the things that intrigues me about this, though, is there seems to be a rediscovery of some of what Leonardo was talking about now. I mean, I'm thinking in part of the fact that people are going back and looking at Leonardo and Galileo and saying, well, what can we still learn from them? But one of the I'm thinking of Michael Gelb's book, How to Think Like Leonardo da Vinci, 7 Steps.
I read that. I thought it was.
It's okay.
Yeah, it's okay.
It's all right. It's a guidebook. It's a place you can start from. I'd still rather go read Leonardo directly. The thing that's interesting to me, though, is we've been talking about punctuated equilibrium and paradigm shifts, and I'm starting to think there's another paradigm shift going on now.
Oh, for sure. I mean, that's the conclusion of both. That's the conclusion of Sex, Time, and Power, and that is that we as a species are transforming into another species. And
McLuhan talks about this too, of course. So yeah. Mm-hmm.
Well, I personally, just the phrase paradigm shift is such a cliche that I hope the next paradigm shift is the refrain from using the term paradigm shift a lot, because it's just in modern culture the last 20 years or so it's just been beaten into the ground. But I wanted to talk a bit more about your latest book, Sex, Time, and Power. And I know when you came to Minneapolis to speak, you had talked about a New York Times review of the book that you didn't like because it was written by a woman who you said was a feminist, and I generally don't agree with feminists, but I had some problems with the book Sex, Time, and Power as well. The basic problem I had with the book is, and I can't argue the science, but the basic thrust of the New York Times piece was that the book had a sort of condescending tone to it, and especially compared when I re-skimmed Art and Physics. I
don't remember her saying that. She did have a condescending tone. In fact, if anything, she was condescending to me.
Well, I think one of the things in the book that, for example, I know you had coined the term gynosapiens for females, and I'm just wondering why you would do that. I know, to me, that was a very off-putting term.
She totally misunderstood misinterpreted what I meant by that. I'm certainly not condescending to women. What I'm basically saying is that the scientists named our species Homo sapiens, which is the Homo refers to man. And I'm saying that the changes that occurred in the human female were so dramatically more extensive than they were in the male that allowed women to discover the concept of time, that it would have been more appropriate for scientists to have named our species gynosapiens rather than Homo sapiens. But in no way was I making some sort of a condescending remark about women, and I felt that was totally misinterpreted. Her review, by the way, was one of the most mean-spirited, totally off-the-wall reviews. She spent the first whole column of 3 columns talking about her and her ideas, and then she never mentioned the fact that I'm a best-selling author of 2 previous books, and then has the gall to say that there's really no new ideas in here. Everything's been said before, which was just, I just was flabbergasted when I read it. On the day that I received her review, I read her review, I received from Johannes Wilbur, who was a professor emeritus of anthropology at UCLA, a nice email telling me that this was one of the most stimulating anthropological book of new ideas that he's ever read. And I now have been invited to 3 anthropology departments to give a talk about this.
Okay.
Because, so you have one person who writes a review and didn't really address the issues that I raised in the book.
Well, the woman's name was Meredith Small, and at the end of the article it says that she was a writer and professor of anthropology at Cornell University.
I read her book. In fact, I even quoted her book a couple times in mine.
Yeah. Well, for example, just to give a couple of examples. Now, and I underlined this.
Rather than you give me an example, well, why don't you let me tell your listeners what the book is about?
Okay.
Okay.
I mean, rather than get into a review of a book that they don't even know what we're talking about yet. The primary thesis of the book is that the human species underwent, or rather experienced, a catastrophe at its very outset, because we humans have 2 physical traits that are mutually incompatible. The first one is that we're bipedal. We stood up. And when you stand up, what happens is that you position a massive intestines directly above your anus, which means that every human is at risk for being turned inside out if they go for a stroll after a particularly heavy lunch. So that means if you look at a picture of the human pelvis compared to other bony structures of other pelvises of other animals, you'll notice that our pelvis is shaped like a great big bowl to hold these intestines, and the little hole in the center of the pelvis is very small. Everything was fine until our brains underwent this hyperinflation routine, and ending 150,000 years ago when we start off, and we had a whole pound of brain tissue. Now, that didn't affect the men as it did the women, because the women now had the biggest brain baby sitting above the smallest boning hole in all of animaldom. We are the only species where when a female goes into labor, she has to call for help because it's such a dangerous experience. We have the highest maternal mortality rate of any other mammal. There's no other mammal that dies in childbirth. Most animals go in the back of the burrow and pump out 6, 8, 10, 12, blub, 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 and they don't die in childbirth. So the female of the human species was facing a stress that the male wasn't. And she needed to form enough mental cognition to grasp the connection between sex and pregnancy, because her life depended on it. So some woman somewheres understood, finally, that the kicking in her belly at 4 or 5 months was a direct result of the transient moment of pleasure she had with a man over there earlier. And then she realized that as a result of having sex, he got her pregnant, and that she now had put her life at stake because she could die in childbirth. And if she survived the childbirth, she understood, as no other female ever had before, that she was going to be saddled with the most helpless child.
I'm wondering about we talked earlier about, the awareness of the growing self-awareness of death. And I'm wondering if this isn't just part of a general awareness, general growth of self-consciousness, period, that happened in the species at this time.
Right. Well,
it's one aspect of self-awareness.
But the thing that is self-consciousness, chimps are self-conscious. They now think that dolphins are self-conscious.
Right. Okay.
But that still doesn't mean that a chimp can't make plans for next Friday. We are the only animal that can maneuver in the dimension of time.
Okay, because we fix time.
We understand time, and when natural selection smoothed out the aerodynamics of a wing, it released into the air thousands of varying species of birds.
Right.
The eye was so essential for the survival of organisms that it has evolved independently 40 different times in 40 different configurations.
Right.
Why is it that humans are the only animal you can make an appointment with in 2 weeks and expect them to keep it?
Well, but one thing though, that doesn't necessarily mean that time, the idea of time, is exclusive to humans. Because again, I'm not a cetologist, but when I've read, for example, studies of whales can, at certain times when they see the light at a certain time, they can pick up songs that they've left off, let's say, a week earlier at that exact same time.
Elephants remember, and I'm not saying that other animals don't have great memories. I'm just saying that the ability to maneuver in the dimension of time is so extraordinary that it separates humans from all other animals. There's no other. The reason that we put them all in our zoos and we're making most of them extinct is no matter how massive or dangerous or agile or fast they are, we'll kill them because we can anticipate what they're going to do, and they can't anticipate what we're going to do.
Right. Okay.
Well, let's take a break here and finish this segment, and when we'll listen to a little bit of music, and when we get back, we'll talk some more with Leonard.
And we are back talking once again with Dr. Leonard Shlain, author of Sex, Time, and Power. And Dan, you had some more ideas about time you wanted to talk about?
Yeah, one of the things that in the book, and actually it's being the second word in the title, is the idea of time. I know we mentioned in the last segment a New York Times review, and one of the quotes was from that was that many cultures do not follow a monthly calendar. And I know, Art, that you know a lot more about shamanism and things like the Aborigines and Maoris and non-linear based time. And I know in Leonard's book, when I saw him speak, when I read the book, his idea was how closely related the menstrual cycle of humans are to the moon and the calendar. But I wanted to just first ask you, Art, you know a lot more about cultures that don't view time linearly, and I'm just wondering how that would relate to Leonard's thesis about calendric menstruation.
Well, one of the things that ties into that rather well is that a lot of, shall we call them pre-industrial cultures, and especially cultures in the East, tend to view time as cycles rather than as linear. The idea.
I rest my case.
Yeah, exactly, and I mean that's part of it, I think, because the Western culture, Western civilization, if you will, is the only civilization that I'm aware of in the entire history and variety of world cultures now and previous that ever developed the notion of time is an arrow that only goes one direction.
And I believe that was because of the invention of alphabet literacy.
Yeah, and
when you read in one direction.
Yeah, and that I need to think about that some more. But I think.
Well, unless you take an Evelyn Wood course.
Yeah, right. Okay, but the idea of cycles of time, many millennia we were more closely bound to nature than we are now.
Well, Art, that's the whole point of my book, and that is
then I'll let you say it.
that women discovered time by undergoing a drastic reconfiguration of their reproductive life cycles.
Okay.
Because there's 3 million sexually reproducing species, and in virtually every single other one of them, the female has a distinct period of receptivity called estrus or heat, or rutting season. She gives off an incredibly clear signal that the males can't possibly miss. We are the one species where the males don't have a clue as to what phase in a woman's menstrual cycle she's in. She doesn't give off a signal. Mm-hmm. And she doesn't have estrus in the chimpanzee sense of the word, but instead she has the most florid menses of any other animal. There is no other species that loses as much blood as much often as a human female. And furthermore, the human female, when she gathers together in a convent or a dormitory or in a tribe, they all begin to cycle in harmony. That's something that other primate females don't do. And the conductor orchestrating this harmony happens to be the moon.
Yeah, so you're talking about entrainment then, really.
Yeah, so she entrains her menstrual cycle with the moon, and chimpanzees have a 37-day cycle, bonobos are 42 days, gorillas are 27. They're all over the place.
Right.
The average length of the human female menstrual cycle is 29.5 days, which happens to exactly equal a lunar cycle. So by entraining her menses with the moon and having menses associated with psychological and physiological changes that she can't possibly ignore, punctuated by the most dramatic sign there is to any animal, which is external bleeding. Over thousands of years, some woman somewhere said, wait a minute, there's a pattern here. This happened last month. Mm-hmm. The word moon, month, menses, and measurement are derived from the same Greek words, and in every culture in the world, there are connections between moon, month, measurement, and menses, amulets, lunar calendars, folk tales, and the lexicon to indicate that something very dramatic happened to our species when the human female reconfigured her menstrual cycle so that she could understand time, because she had to, because she was at risk for dying if she didn't get the connection between sex and pregnancy.
Okay, but let me just jump in, and this is one of the problems that I had with the book. You say women discovered time or reconfigure their menstrual cycle. It has to be clear that you're speaking metaphorically here, because
I'm not saying they did this consciously.
Right.
No, this is natural selection at work.
Right, but I mean, it's not like some cave women were sitting around and saying, "Boy, geez, I'm really having problems, every 37th day. Let's see if we can get it down to 28 points."
No. These are adaptations that occurred through natural selection that came about as a mean. There's no way that the human female can have these without calling them adaptations. They're built into our genome.
Right.
This isn't something that somebody learns how to do.
Okay. Mm-hmm.
Yeah, but I just wanted to make that clear, because I think sometimes in the book too. I mean, having read a lot of science books and whatnot, this is I guess we wouldn't call it anthropomorphizing, since we're dealing. I guess I don't know what the exact term is, but to make it seem as though there are conscious decisions behind these things that are just random.
I mean, I take some poetic license because I write books that are accessible to the public. That's what all three of my books have been repeatedly lauded for. And in order to do that, I could write it in a dry scientific journal style or the academic style, citing every single person.
Right.
Mm-hmm. But that's not the way I write.
Mm-hmm.
I write kind of poetically and using a lot of metaphors. And some people in the academic community want to take exception with that and say, well, you can't do that. Well, of course I can do that. It's called poetic license. And if you're a writer and you're trying to reach a large audience, you can do that. But I also keep putting into the book to make sure that no one accuses me of saying, oh, well, you're getting into creationism or intelligent design. I'm not doing that. I put enough disclaimers in the book to make sure that no one misunderstands me. And if somebody still misunderstands me after all those disclaimers, then I'm saying they're not reading the book carefully.
Yeah, okay.
In your chapter 21, you talk about of sex, time, and power. You talk about incest and dowries, and I just wanted to see maybe you talk a little bit about that chapter, because I found it pretty interesting, because incest is something that generally most people have said is taboo in all cultures, or a lot of feminists do, but that's generally not true. I know Art, I think we've talked in the past, you and I, about how familial relations in some cultures, or some classical cultures, was not really taboo. So I don't know, Leonard, if you want to talk a little bit about...
we now know that, in most other animals, the sons do not attempt to mate with their mothers. I mean, There seems to be among animals an understanding that sons don't try to mate with mothers, even though they could, but they don't. But fathers do mate with their daughters in many other species. They don't seem to have an understanding that this is part of their offspring.
That's true.
My chapter on there is not necessarily, that's not original thinking. That's Claude Levi-Strauss came up with this a long time ago, and that is that humans came up with this concept that to avoid incest, you had to get the girls out of the tribe and trade them with other tribes and get their girls so that you would be able to ameliorate this. But certainly there have been cultures in the world, for example, the Egyptians, they had royal families where they frequently intermarried, but a careful examination of that finds that a lot of times that they called them husbands and wives, but they were more like brothers and sisters, and they would also have extramarital affairs.
Right.
So it isn't at all clear that there have been cultures in the world where there's been gross incest, meaning a father having sex with his daughter, as opposed to second cousins or first cousins and that sort of thing.
Well, and not every culture has incest taboos as strong as, say, the Navajos, where you have to know both your father's clan and your mother's clan in order to avoid any possible, clans mating into a clan that's too close to you.
Right.
And that's very rigid and very formal.
Right.
Traditionally, I mean, but I would, I was thinking of ancient Egypt, and I know there's some vagueness about that, but yeah.
Well, we talked earlier that you were planning a book on Leonardo, and just moving forward in time. You've done 3 books, starting with Art and Physics, and the Alphabet versus the Goddess, and Sex, Time, and Power. Is Leonardo then in the galley stage? Is that going to come out in a few years?
Well, no, I'm writing it now. I mean, when I wrote Art and Physics, I had it was mainly about relativity, and I had a whole bunch of material about quantum. that I was planning on putting in that book, but then the book just got too long.
Right.
So I took all that material out, and I was planning a sequel to that book, which I just can't seem to get around to, because I then went off on a tangent on this alphabet versus the goddess, and then followed up with Sex, Time, and Power. Now I'm sort of returning in Leonardo's brain back to, but it's all, the theme is always the same: more balance between the hemispheres, between the feminine and the masculine, between the right and the left, between the east and the west. We've allowed human culture to get so completely out of whack that we're producing a rather destructive, rapacious species that's destroying the planet.
And at the end of Sex, Time, and Power, you talk about where you think we're going. I guess I'd like to hear you explain a little bit about where you think we're going as a species now.
I think that it returns to that concept of punctuated equilibrium. If there was a caterpillar crawling across the table, and I said to you, would you believe that the caterpillar is going to turn into a butterfly?
Right.
You didn't know that could happen. You'd say it's impossible.
Right.
But it happens all the time in nature. It's called metamorphosis. And I think that the human species is undergoing a metamorphosis right now, but we're not going to turn into something that looks physically different. We're having a transcendent spiritual change that is going to change us as a species as dramatically as a caterpillar turns into a butterfly. Mm-hmm. And the reason I say that is that if you went back and looked at hominid evolution going back 2.5 million years ago, you'd say, well, a Homo habilis picked up a rock on a riverbed 2.5 million years ago, stared at it, and decided that there was a tool inside of it. What a concept. Then sat very patiently and chipped at the edge of the tool until he got a sharp edge, and then he made the same tool for 1 million years, never varied it. Then along comes Homo erectus with a 2-pint brain, looks at the same tool and says, if you turn this sucker over and you nap it on the other side alternately, you'll get a really sharp edge. He made the same bifacial hand axe for the next 800,000 years, never varied it. Along comes Homo sapiens 150,000 years ago. We make some slightly better tools to begin with. We immigrate out of Africa about 70,000 years ago, and then boom, the creative explosion, or the Upper Paleolithic Revolution, occurs 40,000 years ago, and we start consistently burying our dead, creating grave goods, making art. 8,000 years ago, we invent agriculture. 5,000 years ago, we invent writing. 200 years ago, we have the Industrial Revolution, the technological. If you made a chart, a graph,
this is
2.5 million years ago, it would be a flat horizontal line for 2.5 million years, and then it would start to steeply rise, turning into a logarithmic curve for the last few thousand years, the last few hundred years. Now, we know in science that a curve like that does not exist indefinitely. It either collapses, which the human species is at risk of doing, or, more likely, the object being measured suddenly changes state. In physics, it's called a phase change. In science, it's called a metamorphosis. And in evolution, it's called punctuated equilibrium. Well, we humans are at that point where we are in the process of exteriorizing our nervous system.
Let me ask you something, Dr. Shlain, and you're as good a person to ask this. Recently, I had read and done a review of Steven Pinker's latest book, and he talks about eugenics. Now, before you jump in, I think eugenics has gotten a bad name. I think, for example, in the early 20th century, eugenics was misused. I don't think that there's really anything wrong with eugenics or euthenics, the improvement of the species. And I think the idea that we're all going to have a bunch of little Hitlers running around creating super races is kind of silly because, a lot of people are against.
Silly because Lord Acton said that power corrupts and absolute power corrupts absolutely.
But if you have let's say an Arab couple, they're not going to want the ideal of say an Aryan blonde-haired, blue-eyed child is not going to be something that's going to be appeal to someone from Indonesia. And the idea that a parent might want to select qualities that could come to imbue into their kids doesn't seem to me bad. Plus the fact that it totally obviates the idea that nurture has a part in human growth.
But for 3.8 billion years of life on this planet, the only way that life could pass on information was through DNA. And then along comes this one species called Homo sapiens that develops an extra genetic way to pass on information,
which is called culture.
Yes, and language is the medium by which it's conveyed. the limit of human intelligence was set by the diameter of the female's pelvis. You simply could not get a bigger brain baby down to that little bony hole.
Right.
It's been estimated that the human female should be pregnant for 18 months rather than 9 months, but she couldn't wait because any week beyond 9 months, she's at risk for dying along with the baby.
Which is why we're born so helpless and have such a long development.
Our solution was to wait till the baby was safely on the other side of the mother's pelvic ring of bone,
right,
and then start ladling in the information that the baby needs. It's called culture, and the medium that's used is called language. So we have figured out a way to exteriorize our nervous system. All the telescopes, cell phones, microscopes,
internet,
and the reason my computer is colored gray is it happens to be a piece of my brain that's just not, it's sitting on the desk, but it's not wet. So what we've done is we've managed to expand our nervous system, our senses, by coming up with technological advances that have now allowed us to start to tamper with the very genetic instructions of life itself, as you were referring to earlier, by being able to manipulate the genome. But the invention of pharmacological agents, the pill, cesarean sections, extra in vitro fertilization, all these things are dramatically changing this species. Mm-hmm. And I predict that we're in the process of actually changing it to something else. But don't ask me what we're going to look like.
Do you think cyborgs are in the future? Machines and men?
Well, as a surgeon, we implant pacemakers, and I've always thought that the most plentiful substance on this planet is carbon. The second most plentiful substance is silicon dioxide, otherwise known as sand.
Right.
Isn't it interesting that silicon dioxide and carbon-based life forms are beginning to merge in such a way that as Kurzweil points out, at what point when you replace somebody's you're giving them a pacemaker and an artificial this and an artificial that, and at what point do they become a cyborg?
Right.
Yeah. Well, do you think that 50, 100 years down the line that metamorphosis point or that breaking point will be reached, and that there will be, we'll go from Homo sapiens to something else sapiens?
I think so. If you were a Gallup pollster and you were in the 1390s, and you were interviewing all the people who had just lived through this century that had 3 bubonic plagues and 100 years war, and you asked them, well, what do you think the future holds? They'd probably tell you that humanity is going to hell in a handcart. Mm-hmm. Not one person alive then could anticipate that the Renaissance was about to begin.
Right.
Yeah.
Right.
In the 1790s, with all those brilliant philosophers and Enlightenment, all those great Diderot and Voltaire, none of those people could anticipate that the Industrial Revolution was just beginning.
Yeah.
So here we are at beginning a new century where we have astonishing new breakthroughs in all kinds of fields. And when you're in the middle of a spinning washing machine getting battered about, it's very difficult to notice that the clothes are getting cleaner.
Right.
Yeah. Well, excuse me. We're almost out of time on the show here, so I take it that you are an optimist, Dr. Shlain.
Yes, I am. No one could have predicted that you could take an explosive gas like hydrogen and combine it with a combustible gas like oxygen and get water.
Right.
No one, if you didn't know that could happen, you'd say that that's impossible.
Well,
if you look at the whole structure of the universe from the Big Bang to the present, there have been so many improbable events that have occurred that humans have a poverty of imagination. Most people still believe that some old white man with a long white beard is sitting on a cloud directing our affairs, and that when you die you're going to be issued a pair of wings and learn how to play a harp so that you could skip through the clouds without having any sex. That to me is so that just indicates such a poverty of imagination.
Right. Mm-hmm.
And we that the possibilities are endless.
Mm-hmm. Well, and it's good to I'm very glad to hear things being pushed towards the visionary and, even the transcendental, because we don't really know what that means. Just that we're going to transcend what we know now.
We all know. We've all jumped out of the water like that fish I talked about
exactly,
earlier.
Yeah.
We caught a glimpse of something else. We know that something else is there. It remains for us to discover what it is, and that's the big discovery that's waiting to be made.
Right.
Viva A squared.
Yeah. Well, thank you very much for a fascinating discussion. Dr. Leonard Shlain, for being with us on this program.
Might want to mention my website, by the way.
Yes, Dan, do you have that?
Yeah, actually, he's got 3 websites.
Yeah, but if you go to any of them, they all go to the same.
Yeah, www.artandphysics.com, alphabetversusgoddess.com, and sextimeandpower.com are the 3 websites for the 3 books.
And my email is lshlain@aol.com, and there's no C in my name if anybody wants to contact me.
Okay.
Okay. Thanks once again for being with us for a wonderful discussion.
Okay, thank you.
Wow.